Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Friedel-Crafts acylation, UlCl3. Benzene reacts with succinic anhydride under UlCl3 to give 4-OXO, 4-phenylbutanoic acid, a keto acid, pH, CHO, CH2-CH2-Co. This is compound A. Moving on to the next step. SOCl2 converts the carboxylic acid of A to an acid chloride, pH, CHO, CH2-CH2-COCl. Moving on to the next step. NaN3 reacts with the acid chloride to give the acyl azide, pH, CHO, CH2-CH2-Con3. This is compound B. And for the final step, MeOH with the acyl azide triggers a Curtius rearrangement upon heating, or the azide rearranges the acyl azide loses N2 to form an isocyanate, which reacts with MeOH to give a methyl carbamate. However, the ketone is still present. Product after step 4 would be pH, CHO, CH2-CH2NH, CH3, methyl carbamate of the amine. Lyell 4 reduces both the ketone, to alcohol, PHO, and the carbamate, N, CH2-N, CH3, giving compound, CPHCH, of CH2-CH2NH, CH3. Step 6 and 7, Na deprotonates the alcohol of C to give an alkoxide, which then reacts with 4-chlorobenzotrifluoride, an aryl chloride activated by the para-CF3 group via SNAR to displace chloride and form the aryl ether. Heating, delta, drives the SNAR reaction to completion. Product, DPHCH, O-C6H4-CF3, para-CH2-CH2-NH, CH3, which matches option A. Why other options fail? B. Has no nitrogen, inconsistent with the NaN3 Curtius Lyell 4 steps that introduce N-methyl. C. Has O retained and shows N relation rather than O relation, now would preferentially deprotonate the alcohol, pK-16, not the amine, pK-35, so O alkylation occurs, not N relation. Also the CF3 group is meta in C, but the reagent shown is para-CF3. D. Has a paratolulyl group on nitrogen and no CF3, inconsistent with the reagent used. Therefore, the correct answer is A. Therefore, the correct answer is option A.